Everybody, moving on to the next function that we are studying in Algebra 2, which are rational functions. These rational functions are just the ratio of two polynomial functions. So they're going to look pretty similar to what we've already done. The only difference being there's a polynomial in the numerator and a polynomial in the denominator. And what we're really going to focus on today is rational functions and their graphs, and specifically transforming them. So let me go to Desmos and just show you the parent function for a rational function. This is going to be the most basic rational function that there is. Definitely having a lot of issues getting there. There we go. So let me get rid of all this stuff. I mean, still have that up there. Hey, so here's our rational function, a divided by x minus h plus k. So I'm really hoping that the a, h, and k all kind of make you remember something. You should remember those, should ring some bells for you. A, h, and k. Those are the transformations that we used for going all the way back to quadratic functions. So anyhow, here's the parent rational function, just 1 divided by x. There's a ratio of two polynomials. You can see that there's essentially two parts to it. We've got this part on the bottom left and this part on the top right. So these rational functions, they're not continuous over all real numbers, like the other functions that we've studied so far. This rational function has these things called asymptotes, lines that the function approaches but never actually gets to. And they're actually pretty easy to pick out. So on the bottom part, we know that we can't divide anything by 0. So if on the denominator I had x minus 3, and I tried to plug in 3 into the function, just see what happens. It's undefined. At positive 3, the function doesn't actually exist. That's an asymptote. The function doesn't actually exist there. It's a line where we are going to get very close to that value. If I zoom in, you can see our green function's getting close to that asymptote of -3, but it's never actually reaching it. There's also a horizontal asymptote. If I just add or subtract some value off to the end here, we'll be able to see it pretty easily. So here's a horizontal asymptote then at y equals positive 2. So two things to keep in mind. If I add and subtract the value way off to the end, that's not really part of my fraction. It's the horizontal asymptote. And then remember, you can't divide by 0. So if I put an x value in here, and I try to divide by 0, my function's undefined. It doesn't actually exist at that value. So anyhow, that's the real basics of what we're doing today. So let me go back to our note-taking devices, and we'll do the problem. And I think you'll have a pretty good idea of what's going on. Okay, so with these rational functions, again, that's transformation form. You can play around with this in Desmos. I think it's probably the best option for you. It's just type in this function, add sliders, and see what a, h, and k do to your rational function. So anyhow, here's our example. Sketch 1 divided by x plus 2 plus 1. And find the horizontal asymptote, the vertical asymptote, the domain, and the range. Okay. What I would recommend first is actually sketch the asymptotes. Really easy to pick out. So this number on the end, if you remember just what I was saying in Desmos there, this number on the end gives you the horizontal asymptote. That'll give you a flat line that you will approach but never actually reach. So I can sketch that in right here. I know I'm going to go up 1. I've got this line at y equals 1. There we go. And then I remember I can't divide by 0. So what would make this 0? If I plugged in, like just for example, if I did 1 divided by -2 plus 2, well, -2 plus 2 is 0. 1 divided by 0 is undefined. Can't divide by 0. So -2 is the x value that we are concerned with. Something else that we're going to get close to but never actually reach. So this number essentially is how you're going to find the vertical asymptote. Okay, now for sketching it, as long as we haven't made the a value negative or really played around with this x value too much, your two pieces of the function are going to be in the top right corner and the bottom left corner. I'm not going to be too picky with grading on these things. What I'm mostly looking for is the function that you're graphing doesn't actually intersect the asymptotes. You should approach these kind of imaginary lines, these dotted lines, but never actually cross them. Then you just want to make it about the same distance away down here. And then again, just make sure you don't actually cross those things. So your graph looks like this, like homework assignments, tests, quizzes. I would totally give you credit for your sketch. Now let's actually just find these things. So the horizontal asymptote, again, that's the number on the end. Horizontal asymptote is always equal to 1. Y is always equal to 1. Vertical asymptote, the line going up and down, you're actually going to look for the x value. What is the x value for this line? It's always equal to, x is always equal to -2. Now the domain and the range get a little bit confusing if you don't already have the asymptotes. We already have the asymptotes, it makes it a lot easier actually. The domain, the x values can go from -∞ up to -2. We've got the function here in the bottom left. I can go from, -∞ for the x values up to -2. Remember, I never actually get to -2 though. So how we're going to write the domain in this case is we actually have another piece, what the u is for. We can also go from, this piece of our function, this other tail, we can go from -2 up to, and going on forever. So -2 up to +∞. So really just think of it, the domain is going to use your x value asymptote, the vertical one. Because again, if I try to plug in -2, the function doesn't actually exist. The range is going to use this horizontal asymptote, the y value. Range is always concerned with y values. So the range is going to go from -∞ up to +1. The range, I can go all the way up to +1, and then my function levels out, never actually gets to +1. Then it starts out over here again at like 1.000000001, and it can go up forever. So let's just write that using proper notation form. It goes from 1 to +∞. All right, y'all, I think that'll do it for this video. Just have a pretty good idea of what a asymptote is, horizontal, vertical. Domain and range looks a little bit different with rational functions because there's essentially 2 pieces to our function, but that's okay. Hope you liked the video. See y'all in class. Bye-bye.